Hey, everybody, welcome back to another episode of AWS On Air, our flagship show here at AWS On Air. I'm Todd Fortier. I'm a senior solutions architect here at AWS, where I focus on developing solutions for the AWS Solutions Library. If you haven't heard of that, stop now, go over to aws.amazon.com/solutions. Oh, wait, don't stop. Listen, and then go check out the AWS Solutions Library. I am joined by my awesome host, Adrian San Miguel. Adrian, what's this show all about?
This show is all about you, the viewer. And thanks for having me again, Todd. As you mentioned, my name is Adrian San Miguel. I'm a partner enterprise architect at AWS, working with our technology partners principally. But to your question, this show is about you, the viewer, and helping you understand the new and cool things that our various service teams and solution teams are put together for you to consume, to go out there and start building and really scratching that itch curiosity. It is a program that is driven for you and by you, and we are actively monitoring the chat, monitoring questions, taking feedback through surveys to put together more of the content that you, the user, want us to focus on. So when we say that the success of the program and the success of the content is contingent on your feedback, we really do mean it. So with that, Todd, what are we going to be talking about today?
Today is all things SageMaker. So we've got a few SageMaker launches I'm really excited about. I have spent some time in SageMaker. Last week, we demoed a solution called the Generative AI Application Builder on AWS, a solution in our library, and that has an integration into SageMaker. And to kind of give myself a good reason to explore SageMaker and all it has to offer, I connected that solution to that and started using foundation models right in SageMaker. But today we're going to be talking about a new model launch, I think. We're going to be talking about how to train at scale those models. So I'm really excited to get into it and see what kind of happens behind the scenes with SageMaker and learn along with the audience. But we want to know from you, have you used SageMaker? Where are you listening from? Is this your first time watching? Have you watched before? What do you think of all the stuff Adrian's got in his background? That's the kind of stuff we want to see in the chat. So yeah, tune in, ask us some questions. We're live right now.
Absolutely. And as Todd mentioned, we're going to be talking about all things SageMaker. This, for the most part, has dominated a lot of the conversations and discussion I've had with consulting and technology partners over the last year or so, where exactly that, how can I take something that's already there and better fine tune it for my needs? So I'm personally really excited to be getting into this. And I think we have a bit of an ongoing debate, at least amongst the show's hosts in the last couple of days, about what the favorite, what the best fall themed drink is. I've got my very firm vote in the corner of a good Mexican mocha made with old fashioned chocolate the right way. Todd, I don't know about your choice, man.
See, I am lame. I am just coffee from every morning until like 4 in the morning until like nap time. And then it's a hard Celsius. So unless they make a pumpkin spice Celsius, I am yeah, I'm just coffee all day long. I might throw a little bit of like cinnamon or something in it just to be festive at a campground, but that's about
A pumpkin spice Celsius, dude. I literally can't even process that you just said that. But hey, it is what it is. We're here. I still hold you in the same regard, a slight bit of contempt, but hey, it is what it is.
Dude, I'm a weird dude. Yeah, I do. I'm not even gonna try to explain it. But hey, Adrian, this is just one show of many shows that we have here at AWS On Air. What are some of the other shows? I'll kick us off. One of my favorite shows, the sports show. We are getting into my favorite part of the year when it comes to sports. NFL. So there's some next generation stats on the NFL. I've seen a bunch of stuff about that. So hopefully we see some shows on the AWS On Air Sports Show with our producer, Nick. It's also getting ready to be hockey season. I'm a huge hockey fan. So I'm all things sports. What about you, Adrian?
Well, I too am all things sports, huge Rams fan, huge Astros fan. Believe it or not, a Red Wings fan over at Texas Stars or Dallas Stars fan. Sorry,
fighting words here.
They are fighting words, but if it wasn't fighting, it wouldn't be hockey. But I digress. We got under the hood with one of our hosts named Art. We've got startups with Jillian Ford, game day with the incomparable Anne Berbeni. We also got Data Dive, and just a handful of different hyper-focused shows and content put together based off of what you want to see. So we're definitely listening. We're definitely actively taking that feedback. So if there's something that you're not seeing, by all means, we need to know about it so we can go ahead and put that together for you.
Dude, it is a great time to be learning about AWS. When I started learning about AWS, I
Mhm.
had just a few blogs, YouTube. There's just a handful of services. I remember reading some of Jeff Barr's early blog posts, who's a regular uh, uh, person on the show. But now there's live shows, live streaming. There's
Mhm.
tons of content on YouTube. There's all kinds of interactive things that AWS is launching, so you can learn. There's new certifications being launched all the time. So man, plenty of stuff to learn. But today we're learning about Amazon SageMaker. So Adrian, if you're ready, I think we're ready to bring on our first guest and jump right into this.
I'm ready. Let's do it.
Yeah, let's do it. All right, we are kicking off our first segment of the Friday today with Alex. Alex, welcome to the show. Please introduce yourself.
Hi, thanks for having me. I'm Alex Jankolski. I'm a principal solutions architect in the worldwide specialist organization at AWS, and I focus on orchestration of ML and AI workloads on AWS using containers. So that's just a fancy way of saying I like to run stuff in containers at scale.
So you said worldwide specialist. So you are a containers specialist. You know everything about how to containerize and scale on AWS.
Um, I like to run everything in containers. I'm not in the container specialist organization, but I'm in the frameworks team and generally in the worldwide specialist organization that has many different specialists that um, specialize in deep in areas of the entire Gen AI stack on AWS.
Interesting.
Yeah.
Interesting. Yeah, I knew we had some divisions inside, but I didn't know we had specialists on uh, hyper focusing on that. So welcome to the show. Thank you for spending some time with us. But before we go on, Alex, what is your favorite fall themed drink? Do you have one?
I actually don't have a favorite. I like
Okay.
many of the fall drinks. I like pumpkin spice. Um, I'm happy to try anything new. I like new experiences.
Awesome.
Hey,
Awesome.
maybe
Thank
we
you
can
so
I think we're going to be talking about some fine tuning some models, so maybe we can kind of get some new flavor suggestions through SageMaker. But Alex, you
much.
mentioned containers. When I think containers, I think Kubernetes, right? I think Docker, I think Kubernetes, and we have a service here at AWS that does some of that work for you. And I think we're going to be talking about that a little bit. Can we talk about? Can you introduce the topic and what we're going to be getting into today?
Yeah. So the challenge is models. As you said, models are getting bigger and bigger, and especially foundation models require intensive training with specialized infrastructure and accelerated compute at scales that are, in the thousands and of tens and hundreds of thousands of accelerators. Um, and that is to support the size of models, which is now in the billions of parameters, and going towards trillion parameters and beyond. So at that scale, first of all, it's very expensive to do. And second of all, if a hardware failure occurs, and anyone that's run hardware knows that hardware fails sometimes. When hardware failure occurs, it is very expensive to stop the job, to troubleshoot where the failure is, to remediate it. It could take hours to do that manually, which equates to longer training times and lower utilization because all of the accelerators that are just sitting idle are just incurring cost while not being used. So that is why, listening to our customers, we built SageMaker HyperPod, which is a service that automatically monitors and detects hardware failures in large-scale infrastructure and remediates them on behalf of the customer. And this week, we released Amazon EKS support for SageMaker HyperPod, which now means that you can consume the HyperPod service through the very popular Kubernetes interface.
I got it. So we're talking. This is done through SageMaker. And Alex, I'm sure we've mentioned this already. We're a live show, so we actually have audience asking questions. We got our first question in the channel, so I just want to take a minute to make sure we get to that. The question is, what are some of the most innovative or unexpected use cases you've seen with Amazon SageMaker in industries like cybersecurity or cloud optimization? Whew, that's a question.
That's a good one.
Wow.
Yeah, we
Unusual, innovative,
Yeah.
innovative or unexpected use cases. What, anything that like models might be trained for? I mean, I know I saw something recently on protein folding for drug research. That's models that I've seen a bunch of stuff about sports, like I said, because I've been all these new tackle statistics that are being launched in the NFL. Those are some of the ones that I've seen that are really cool. Alex, do you have anything?
Yeah. Gen AI and deep learning has permeated every level of life, and use cases, as you mentioned, from protein folding to computational fluid dynamics and healthcare. Security is actually a tough one, but fraud detection in the financial industry, autonomous driving, that's a really cool one. And content creation. Art is never going to be the same anymore. So use cases are really cool, and they're all enabled by this new advancement in generative AI that we're seeing in life.
That's right. And if you want to do that at scale, SageMaker is one of those services that can handle that kind of capacity. We've got another question in the chat. Like, at what scale, is there a scale in these models where we start hitting diminishing returns on the number of parameters? I know these models are getting bigger and bigger and bigger. I don't know if there's such a thing as diminishing. I imagine it's somewhat correlated to the amount of computational power that can sit behind it. But Alex, what do you think about that?
I think we're still in the beginning of the journey. The scale we're seeing now is still difficult to compare to the capacity of the human brain in terms of number of neurons that we have in the brain. So it's a balancing act, the returns that you're seeing and the investment you're doing, but hardware and networking is getting better and the models are getting bigger. So hopefully we're able to move both of these in the same direction together.
Nice. Alex, that kind of brings me into just kind of wanting to better understand what this is going to look like. In my mind's eye, coming from an ops and data center background, I have an idea of what the service would potentially do based on the way that you described it and the complexities therein, and making sure that we get the scaling right without, taking false positives and taking action when we don't need to. Any chance you happen to have a demo what this looks like and be able to walk us through it?
Yeah, let me do a quick screen share here and pull up. First, I have a slide that I can show you to kind of describe what it looks like in terms of architecture. So as mentioned, SageMaker HyperPod is a managed service, which means that your compute nodes actually live in a managed account, and that's where they're being monitored, deep health checked, and constantly observed for any hardware failures that might arise. And when they do arise, there are workflows that remediate those failures for you quickly. Nodes get either rebooted or replaced depending on the type of failure that's occurred. This service, this compute can be consumed either through a Slurm interface or through EKS now. HyperPod supports both starting this week, with EKS being the new capability. And in case of EKS, you would have an EKS control plane, which is in a separate service VPC managed by the EKS service. That you can think of this as being your controller node, or it's also in Kubernetes terms called the master node in the cluster. You interact with your compute by sending commands to the control plane through a command called kubectl. In your own VPC, you actually don't have any of the compute, but you can store the data in Amazon S3 using a shared volume with Amazon FSx for Lustre, storing your containers in the Elastic Container Registry, and your log information in Amazon CloudWatch. So this is what the architecture looks like. If you want to get step-by-step walkthrough on how to use HyperPod with EKS, we've just published this week Amazon EKS support in Amazon SageMaker HyperPod workshop. So this workshop, we'll share the link, walks you through step-by-step all of the low-level commands to create a cluster, to run some examples. For example, this is a fully sharded data parallel training of Llama 2 and Llama 3 models on HyperPod. You can also run this against the custom-built accelerators by Amazon called Neuron devices. They're provided by our Trainium instances. And you could also use HyperPod for inference workloads. The workshop ends with teaching you how to clean up everything that you have created as well. And this workshop will be presented at reInvent this year. If you're interested to attend and get hands-on experience, as well as you can do that on your own, in your own account. I would like to show that you can have a homogeneous cluster, but also you can have different instance groups in your cluster if you wanted to have different processors and direct your workloads to different instance types. A full-scale demo of having all of these instances will be published on YouTube video later.
Awesome.
For now, I have just a smaller version of this with CPU and A10 GPU instances that I'd like to share with you here.
Yeah, let's see it.
All right. So
Alex, real quick, before you jump into this, we've got another question in the chat. I want to make sure I get to it before we get too deep into this demo. Now, when we're talking about instances, we're talking about EC2, different compute style instances. But we have a question in the chat. Can we run this kind of architecture on Lambdas, or is that's something totally different?
You can run containers on Lambda, but not GPUs or accelerated compute. And when you talk about foundation model training, you do require accelerated compute because the computational requirements of the workloads are so huge that it's just not conducive to basically build supercomputers on Lambda. What we're talking about here is running supercomputers in the cloud.
That's super. So you got a super demo to see some of these supercomputers in action?
Hopefully, yeah. So I cannot possibly get through all of the commands that you need to run within 10 minutes. So I like running things in containers, as I mentioned, and that is why I've built this container for you that already has all of the commands kind of packaged in here, and I'm just going to run through it real quick so we can do this quickly. The project was also open source this week. It's called AWS Do HyperPod, and just helps you get started with HyperPod and do things on it quickly. So I've cloned the project here. If you run the build script and builds the container for you, then you run the run script, it starts the container for you. You can see with the status script that the container is up and running. Every time you do something, it actually tells you the actual command that it is running, and we can see this container has been up for 5 hours. I'm going to exec into the container. Basically, I'm getting a shell into this container. And now I have all of the tools in the shell and scripts, like all the automation that's needed to operate and work with HyperPod. So one of the things that I have here, let me make this screen big, is the HyperPod CLI. So if you don't know much about Kubernetes or kubectl, this HyperPod CLI provides a scientist experience where they can just use this simple command line to look at what compute is available, start training jobs, manage them, look at the logs of these training jobs, and basically operate the scientist workflow against a huge cluster of accelerators, GPUs or Trainium, with this simple interface. I also have some automation scripts here that help you list your available clusters, create a cluster, update it, delete it, and so on. If you like to see things more graphically, there are tools here like EKS Node Viewer, which show you the distribution of your containers, your pods inside the cluster, as well as if you don't like operating, like typing kubectl commands. By the way, instead of typing kubectl, I'll be just typing k. It's the same thing here. There are many, many shorthand aliases here, which you can see by typing alias, and that helps save on typing and also reduces the number of mistakes I'll make while talking and typing at the same time.
Nice. Hey, Alex, so we've got just a few more minutes, so I want to make sure you get to the core of this. I want to see this supercomputer in action, this container. We're inside the HyperPod. That's my favorite sentence I've said all week today. Let's see what happens.
It feels like pumpkin spice, doesn't it?
Oh, and everything nice. I like what you did there.
All right, I'm just changing to a model training example here. We're going to run a PyTorch job, and we'll train a very small ImageNet model. We'll apply this manifest. The left one will run on CPUs, and the right one will run on GPU.
Alex, are you setting up a race here? Is this going to be a race?
Looks like a race.
Yeah, that could feel like a race. So there, I have set it up, one click, and then both go at the same time. And now I am going to watch the pods here on the left side and see they've started running already. So what we'll do is we'll look at the logs of the CPU pods on the left side, and we'll look at the logs using a tool called kubetail. KT is just an abbreviation. The GPU pods on the right side. So here
my
you
money's
go.
on GPUs.
My money's on CPU.
Has started on both sides, and you can see on the left we have 2 nodes with 4 actually, let's look at what these things are doing. Getting the nodes here in the cluster on both sides. We have two M5 instances. These are CPU instances, and one G5 instance, which is contains a single GPU. So if we look at the CPU utilization, and this here is a shorthand for I want to look at this node particular, which is a CPU node. This will show us the utilization for that node. And you can see 4 CPU cores at 100% utilization. This one, if I look at GPU utilization for the G5 instance, which is, it's enough to just identify it with a unique substring of the name. It will show us what the GPU is doing. And we can see here that GPU is being utilized at about 60% maybe, and the memory is even lower because this is a very small model. So though this is a very tough task for CPUs, for GPUs, it's kind of...
Yeah. So that's what we would expect. We'd expect the GPU, a little bit more computational power, to be running a little bit more efficiently at scale. And we could do that because we can do these things at scale because of HyperPod and some of the commands. Hey, Alex, this is a really awesome demo. And I love seeing this kind of graphical interface in the command line. I think that's like, it almost makes me feel like we're in like an episode of some futuristic sci-fi movie. But Alex, if customers wanted to learn more, where would they go to learn more about this? We got the workshop.
Yeah, so there are a number of resources. Everything that you saw here actually is made by using the workshop, the Do HyperPod project, and the HyperPod CLI. There's the awesome distributed training project, which my team maintains, and it has many examples of how to run distributed training at large scale on accelerated infrastructure.
Very cool. Hey, Alex, thanks for coming on.
My pleasure.
Thank you. Dude,
hey, Adrian, that's a cool demo. Sorry, I keep cutting you off, man. I'm having some weird thing. It's like kind of jittery. I don't know.
No, you're good. You're good. I literally just only said the word "so." Like, so that's being able to take the reckless, TVOFH, if anybody remembers that acronym, of the person that wants to help and kind of doesn't. That was me touching anything having to do with Kubernetes, dating back to making this easy to scale up, scale down without having to guess and do that auto triage and healing. That's pretty awesome. I'm actually going to go through it in my personal account here in a little bit after we're done, because I know what I'm going to take her on next week.
Yeah, we've got a few comments on those UIs too. So I think, that's very cool stuff. And man, there's always something new to learn here at AWS. And I want to know what our audience wants to learn. We have a survey where you get an opportunity to tell us exactly what you want to hear on this show. What kind of demos, what kind of services, what kind of people do you want us to bring on? Let us know how we're doing. Let us know what your favorite fall drink is. I mean, anything. Our goal, really my goal, is to do as many of these surveys as we possibly can, because I've made some commitments this year. Mike, one of the commitments I made was if we get over 100 responses, so the first 20 respondents get $19. But if we get over 100, and I've committed this publicly, I will not only write, but I will record a metal song under the moniker Goatman, and Nick will feature on it. Adrian, you want on some of this action? Should we just do an AWS OnAir metal concept song? But we got to get over 100 survey respondents. I know we can.
I'm down. Nobody ever wants to play bass, so I can go do that. If not, I get up. So one way or another, we'll figure it out. Might even put my dog to strap a tambourine to his tail and see what we can't put together.
It's funny. I played bass when I first started playing guitar. I started playing bass. And the reason why is exactly that. Nobody wanted to play bass. Whoever was the worst guitar player among the group of friends, that's the person that played bass. And that was always me. So I've gotten better. So I actually got pretty good at bass. And then I was like, I want to play guitar. So, so it's cool. I think basses are cool.
It is. I think back to the early days that got me gravitating that way. Cliff Burton, Obviously, Lemmy, goes without saying. Steve Harris, start thinking of the metal heroes, like, hey, it's pretty cool. They look pretty cool doing it, so why not? And then they're like, no, you're too big and lanky. You need to go sit behind the drum set. So that's how it ended up.
Nice. Hey, so we've got another sponsored segment this week. Should we bring on our sponsor, NVIDIA? And I think actually this is going to be a segment I did. So you might see me again, different outfit. We recorded this one a few days ago. So should we bring him on, Adrian? Let's do that.
Let's bring him on, but you ruined the mystique. You should have said that we'll be right back. Quick costume change, but there you went and did it.
I just don't know if I can pull that off.
My
desk is all different. Okay. My desk is all different. My outfit's different. I don't think people would have bought it.
It is what it is. Can't hurt for trying anyway. Let's get to it.
All right, Nick, roll the tape. Hey, everybody. Welcome back to another AWS OnAir sponsored segment brought to you by NVIDIA. I am Todd Fortier, a senior solutions architect here at AWS. And today I am joined by Eliuth from NVIDIA and Vara from AWS. Eliuth, why don't you introduce yourself and we'll kick this thing off.
Thank you, Todd. Yes, my name is Eliuth Triana. I lead all the global developer communities on AWS, so we can help you accelerate all of the Gen AI optimizations for GPUs and for AWS when you're running your Gen AI. So today we are going to talk about NIMs. NIMs has been very popular. Jensen, the NVIDIA founder, has been talking about NIMs as the tool to optimize Gen AI. So let's learn about what the NIMs are, how you can deploy NIMs on EKS. So that's going to be today's session.
Yeah, thanks, Eliuth. Welcome back to the show. I think we've talked before. It's good to see you again. And Vara, why don't you start by introducing yourself as well?
Yeah, sure. Thanks, Todd. Thanks, Eliuth. Hi, everyone. My name is Vara Buntu. I'm a principal open source solutions architect working with AWS strategic accounts mainly. And today I'm going to talk about the data on EKS as one of the open source projects and how we can use data on EKS to actually deploy NVIDIA NIM inference containers on EKS. So we will delve more into the demo and other things as a part of this session. Yeah.
Cool. Thanks. Yeah. Welcome to the show. So we've got NIMs. That's a product we've heard before on this show. And we've also got EKS, and we're going to talk about how they can be joined together to supercharge some AI ML inference workloads. Eliuth, let's start with you again. Remind us what NIMs is and what do customers get from using NIMs?
Absolutely, Todd. So our team has been working really hard with so many customers and partners in optimization. So optimization on top of the GPU is all when you are running Gen AI workloads. So either doing training or inference, you have to make sure that you optimize using the right software on top of your GPU instances on AWS. So today we will run our NIMs, which is, as Vara was saying, NVIDIA NIM solution. It's a container that you can get with a runtime to run your inference performance workloads. So whenever you are running your inference for your models, you can run it on an NVIDIA NIM that will be state-of-the-art performance. So it has all the optimizations within the container. So you can run it on the specific GPU. You can run it with the specific techniques like sparsity or like any other techniques that can help you to get the best performance. Whatever you do is like this container will help you to get best latency, accuracy, and throughput for your performance models. So let's go to the slide. In the slide, we will see how you can get the difference between doing all the optimizations yourself versus doing all the optimizations using the NIM. So first is you can learn that it will be easier to deploy, so you can run it anywhere. You can be secure, so it will contain like the secure environment versus the open source environment. When you have to secure it yourself, the NIM will be a secure environment already. It is like an optimized infrastructure, optimized technology. So for the right GPU, it will have the best performance. It will have custom code. So for any other model that you will be running, and it will be like our NIM factory. So we will have ongoing maintenance for the NIMs. So it will help you to reduce the time for optimization on your inference workloads. Let's back to the stage, so we can just select a few features that we can have on this engagement. One is you can deploy anywhere your NIM container, so you can run it on EKS, or you can run it on SageMaker, or you can run it on EC2 GPU instances. It would be a simplified deployment, so it will be easy and really simple for you to deploy those NIMs. There will be like a day zero support. You will get all the support from either NVIDIA and AWS on your runtime environments. It will improve the TCO, so you will make sure that you have the best performance for the GPU you are running. Accuracy, latency, and throughput are the features that you will highlight using the NIMs, and you will get all the performance running an enterprise software. So we have this licensing mode, which is NVIDIA AI Enterprise licensing mode, that will help you and will give you all the support and all the backend from NVIDIA to help you run your inference. So with that, what we're going to do is deploy on EKS, so you can see some examples. You can see how easy it is to deploy, and we will be here to answer your questions.
Okay, very cool. So Vara, I'm assuming that's what you're here to do. You're going to show us exactly how we can run the NIMS product inside of EKS, which is an AWS service. Let's first start with EKS.
Yeah.
Remind our audience what EKS is and why they might want to run NIMS on top of EKS.
Yeah, sure. Thanks. So just to start with, Amazon EKS is a fully managed Kubernetes service. It's so a lot of you know about Kubernetes, and AWS's managed service is called Amazon EKS. And so when I say fully managed service, it's mainly the control plane. It's a fully managed service, and the data plane itself, the users will leverage various EC2 instances or a Fargate, various type of compute, and deploy their containers on EKS. And that's pretty much what Amazon EKS is. And then moving on to deploying containers, like Elliot said, NIM is a container. So today, if you want to deploy any of the inference workloads like Llama 2 or Llama 3, or even Mistral, so those kind of models that you can deploy in Kubernetes, which is, in our case, is Amazon EKS, as a container, and then you scale horizontally and leverage the container orchestration capabilities that Kubernetes provides. And that's what we're going to look at today, and how you can easily deploy and manage and scale that to a large scale workload.
Yeah, very cool. So, okay, I got it. Containerization, NIMS comes prepackaged as a container, and we can scale that on EKS, a managed service on AWS. Okay, so you've got a demo for me. Should we see this thing in action?
Yeah, sure. So
Cool.
let me share my
Let's bring it
screen.
up.
I might be moving my head both the sides because I have two screens. But as you can see here, so let me start with the data on EKS. And you heard about Amazon EKS, but data on EKS is an open source initiative we started a couple of years ago. This is mainly to help our customers to scale data and ML workloads on Kubernetes on EKS. So this consists of a bunch of blueprints to deploy various data solutions, and also ML solutions. Comes with best practices, benchmarks, and some of the resources. So this is a useful tool if you want to get started with doing any AML workloads or generative AI workloads. You can start with the data on EKS. So today, I'm going to show you the demo how you can actually deploy NVIDIA NIM, using data on EKS blueprints, and show a couple of examples. And we can send some test prompts to verify the NVIDIA NIM blueprint. And then we can look at some of the Grafana dashboards as well to see the visualization of the NVIDIA NIM deployment. So without any further ado, let's get started. So as you see here on the screen, if you want to get started with the generative AI, I would click on the generative AI button there, explore that. And because we're looking at NVIDIA NIM, we have a number of patterns here. We have training and inference. Because it's an inference pattern, I would go to inference. NVIDIA NIM runs on GPUs. So I'm clicking on GPUs. And this is the blueprint I'm talking about, NVIDIA NIM LLM on Amazon EKS. So if you are thinking about deploying NVIDIA NIM on EKS, I would say this is the best place to start with. You have all the data and clear instructions on how to deploy it. But I won't be doing that as a part of this demo. Probably deploying the solution probably take around 17 minutes. When I say 17 minutes, that includes creating an EKS cluster, deploying the nodes, and deploying NVIDIA NIM and so on. So for that sake, so we're going to skip some of those steps and I'll jump on to show you the cluster and other things. Yep. So, and this is I would like to show you this architecture. This gives you a little bit of overview before I jump into the demo. As you can see here, this is the blueprint that we are deploying as part of this, the deployment, NVIDIA NIM deployment. So NVIDIA NIM provides multiple models that can be deployed in EKS. The way we do it is, in this case, we are using a Helm chart. And within the Helm chart, you can specify which model that you want to deploy. But for today, I'm going to show you Llama 3 8 billion parameters model that we're going to deploy it. And we can see some scaling using Carpenter auto scaling. So when you deploy, you can have one replica, one container running on EKS. But then by using horizontal pod auto scaling with custom metrics using Prometheus and Prometheus adapter, and you can choose, in this case, I'm using number of requests running. And then you will see the number of pods scaling horizontally and creating new nodes and new pods to actually take over the load and horizontally scale the whole workload. And this is like an EKS cluster. You see the two worker nodes, G5 2x. In this case, I'm using the smallest instance that we're going to see in a minute. And these pods are backed by a NIM K8 service, exposed by the NIM K8 service. And even that service is backed by the load balancer. That means the users who are consuming this will be using the load balancer that can be NLB or ALB, but I'm using NLB with Nginx here. That's another pattern. And then you can send prompts to these nodes and get a response back from the server. And the scaling happens to the Prometheus. And the most important thing is these models, when you pull from NVIDIA NIM, and we are storing these models as a cache in EFS here. You see that we are leveraging Elastic File System as a shared file system that can be used by across all the pods. Even if the horizontal scaling kicks in, they're all connected to the EFS and pull the model and then leverage the model, which is nice. We can take a look at that in a minute. So that's kind of an end-to-end architecture. We're going to see all of that in a minute. So to start with, simple instructions, and you clone the repo. You need NVIDIA API key. So before you start working on this, deploying this, and there is a developer key, probably Elliot can answer that from NVIDIA, and you can go and get the developer key, use that key to deploy it, because that's what, but if you want to run it in production, you have some licensing things that you need to work with NVIDIA there. But then from the EKS perspective, if you have AWS account, and then you can go and deploy it. You don't need any specific license, but just make use of, think of like usage of what you're deploying for it. You pay for those instances.
One thing, but add to that is you can get that key from nvidia.ai.com.
Cool. So we're gonna take a look at that, and we have some instructions around how you can get the key here. We kind of explained it in more detail, and then shows that key, how to extract the key, how that key can be used within the deployment. We export it. And then finally, that's one command, install.sh, that goes and deploys your cluster, deploys your model, and make that model ready for you. So I'm going to show you the code in a minute to see exactly where the NVIDIA NIM is getting deployed. So switching back to my VS Code here, and that's the deployment.
So Var, this is code that you got from the GitLab, the GitHub repository that was available. So you ran through the prerequisites, make sure you had everything set up in your AWS account. You have an API key, pulled the code down. Now we're looking at the code. Okay, yeah, let's go through the code really quickly, because I want to see this thing in action and make sure we have enough time to see some inference.
Yeah, sure. So, right. And this is the blueprint. And the key thing I wanted to mention here is I won't go through that. All this code is written in Terraform in this case. We have other, it's mainly focused on the Terraform, but if you are thinking of using some other infrastructure as a code. We can easily convert into that. But then the key thing here is this deploys an EKS cluster, and that goes and deploys an EKS cluster. We won't go through that code anymore. But then we are using Carpenter to scale the nodes. So that's one of the add-on that goes in. Carpenter is an autoscaler from AWS, and that runs on Kubernetes and EKS in this case. And that will help you to actually spin up these instances at runtime based on the workload. And then moving on to the key variables. So to deploy NIM, to make it easier, what we did, we automated the solution using the NVIDIA's NIM Helm chart. And all that you see here is I have two options here. I mentioned two default values. One is deploying Llama 3.1 8B instruct and deploying another model, Llama 3 8B instruct. So you can enable and disable the model, and you can also add multiple models within that variables. And then you go and run Terraform apply that goes and deploys all those NIM containers. That's the simplicity. But then now switch on to the cluster. Yeah, that's a question.
Yeah, no, I just wanted to clarify. So this code is already done for you. It quickly, you can add or customize that code to your liking, add in additional plugins. But you've already deployed that code into an EKS cluster. And now what you're showing is actually interacting with that. And we've got just a few minutes left. So I want to make sure that we get a chance to infer some things against steps.
So let's do because the model is deployed, I'm going to switch back to the Lens. It's an open source tool. Not open source license tool. We can visualize that. And as you can see here, this is an NVIDIA NIM container that I deployed as a part of this. This one pod running at the moment. And we can access the NIM to access and send a prompt. I actually deployed an open source OpenAI web UI. And that's another part, which is talking to the NIM and get the response back. I want to give you something similar to what ChatGPT is like. You can send a prompt and get a response back. Let's go to that deployment. Let me show you real quick, switching on to another browser here. Okay. So as you can see here, I actually connected to this. This is open web UI. I connected to the model that I deployed, and I'll show you the code in a minute. That one, and this actually talks to the EKS model deployed on the container, and you can ask any question here. So this is going to get send a request to the NIM container, get a response back using Llama 3 8B instruct, and say, do you have anything in mind, Todd? Second type.
Not that I can think of. How about hey, there you go. I see. What is generative?
I'm gonna put what is NVIDIA's NIM and see what comes out. That's right. Right, there you go. Wow. You're getting a response back as something, it's pretty awesome. It's an OpenAI server. Yeah, go on top.
Yeah, that's super fast too. So I just want to real quick recap. We're running out of time. So we have the NVIDIA NIMS product that you can use. It's already been containerized for you. You can find that code on the GitHub data on EKS, and then we've deployed that container into an EKS cluster, which is managed by AWS. And then from there, we can use tools like Carpenter to scale more clusters or scale more pods and nodes to get really the most performance out of NVIDIA NIMs. And a lot of that work is already done for you. So if you're interested in learning more about NIMs, there's a blog that we'll have a link to, or you can go to data on EKS and follow the tutorial and get started really quickly. Hey guys, thanks for coming on the show. That was a really cool demo, and I hope to see you again next time.
Yeah,
thanks, back to you guys in the studio. Hey, that's me in the studio.
That is you in the studio. And when did you have a costume change?
When did I've been wearing this the whole time. What are you talking about?
Yeah, have you? Because I'll be real honest with you, man. I just look at your face. That's scary. I think this is the case. You're not trying to pull fast on me, are you?
Not only did I have a quick costume change for that segment, I also had time to install a monitor on my computer, so you might notice the difference there. So like I'm just bang right in the transitions, just like super
Wow.
fast.
Dude, you are super effective. All I did was drink more water. I also did keep an eye on the chat while I was going through those rocket session. Definitely going to be picking those guys to see what I can get figured out. But I did want to call attention to a question that I saw, I believe, from Dave Wawa, if we could bring that up. It's actually a question that many partners and customers have been asking for quite a while. The concept of cost savings has been hitting us pretty hard for probably the last year or so. And I hear this question a lot from customers about, given the resource intensive nature of these type of resources, what can you do to help drop that cost down? There's a lot of different answers and strategies that could be incorporated up until say, I want to say mid-July, but we just recently had a update and release for the capacity block service that we offer so that customers can go through, kind of have an idea and time box the parameters and determine what type of testing and what good looks like. Leverage capacity blocks for EKS, go run their experiment, validate that their findings are done, and then it just kind of dies down. You go about your day. You don't have to worry about additional spend. Don't have to worry about spinning down clusters in the right way. Don't have to worry about having to double check, triple check to make sure everything got spun down. That's the beauty and the nature of the service. You can use it in addition to everything that you're using, so you don't have to go and build and maintain something else. Historically, I've seen folks using startups, various types of startup scripts and teardown, cluster management, etc. But given what we're doing in this space, it's pretty exciting and a relatively intuitive way to go about and do it. And if you have any additional questions, be sure to ask. We'll happy to get them to get to them or get you to the right people who can help you answer.
Yeah, Adrian, cost optimization is something as SAs we talk about a lot. In fact, it's a pillar of our well-architected framework. We are always thinking about how we can save our customers more money by offering free tiers, by offering pay-as-you-go pricing, on-demand pricing versus provision pricing. So there's all kinds of ways that we can save costs at AWS, and that's a great example within EKS on how to do it. But we should keep the show moving along. We've got another guest. We've got a whole nother segment. We're still talking SageMaker. We're still talking generative AI. So, Adrian, if you're ready, let's bring on our next guest.
Let's do it.
Alrighty. Hey, welcome to the show, James and Saurabh. You know, I almost changed my shirt again for this segment, but I decided to stay with the greens for now. Hey, welcome to the show. Let's start with some introductions. I don't know who wants to go first. Maybe Saurabh, you can go first since you're up on my screen first, and then we can do James. Go ahead, Saurabh.
Okay. Hey, Todd. Hey, Adrian. Thanks for having me. Saurabh here. I'm product manager for SageMaker Inference. Excited to talk about Llama 3.1 and JumpStart here today.
Cool.
James,
Thanks. Welcome, James.
Yeah. Thanks for having us on. My name is James Park. I'm a principal solutions architect. I belong to strategic accounts, and kind of cool on what I think is very cool is, my customer is Amazon. So just like we have other customers that we serve. Amazon is another customer of AWS, and now I get to work with teams across Amazon to work on generative AI. So
no pressure.
Yeah.
Yeah. So they're watching. Everybody at Amazon is watching today. No, James, this is one of the cool things that I love about working at AWS is like when I was a developer, we talked a lot about eating our own dog food. That was a term that got thrown out way too often. This has kind of become cliche in the developer world. But that's something we do here. Like Amazon uses the services that we develop at AWS because just like every other company, they are trying to scale, trying to be efficient, trying to cost optimize, trying to find ways to do things better. So I'm really glad that you mentioned that. James, so we're going to be talking about Llama. Let's get into it a little bit. SageMaker JumpStart. Now, I know SageMaker has got a lot of different components to it, but we're talking about JumpStart. What is JumpStart, and how does that fit into the SageMaker ecosystem?
Yep. Yeah, so the way to think about it, Todd, is like SageMaker is a fully managed capability that helps you build, train, and deploy machine learning models, right? And SageMaker JumpStart is a model hub for you to discover latest foundation models and pre-built models, so you can quickly deploy them or fine tune them and play around with them.
So $1 million question, a question I get asked literally 20, 30 times a day. Why would anybody want to go through and fine tune a model? Isn't it just good enough to get going?
Yeah, I mean, it's at the end of the day, like depending on your use case, like you may want to just kind of use the foundation model out of the box, right? Like maybe do some prompting to it and then just use it in your application. But if you want to kind of take that model, kind of show it some of your custom data and kind of fine tune it so that it's more precise in answering questions specific to your business, then you may want to kind of go ahead and fine tune the models. And with SageMaker JumpStart, like we give you kind of a seamless capability to discover a foundation model and then kind of one-click deploy it, or and as well as one-click or within a few clicks fine-tune it and then deploy it for into your production or for your testing.
Interesting. You mentioned
we talk about generative AI quite a bit on this show, and one of the things that and I wish we had more time to really dig into what are some of the various aspects of generative AI. When we start talking about like these different numbers and these different constructs within generative AI, we're talking about how the size of the model, how many parameters went into the model while it was training. And that kind of gives you some sort of idea of what it's capable of doing or how capable it is. But it's not going to know specifically your data. It's not going to know because it's been trained on some, whoever developed the model has trained it on the parameters that the different corpuses of text. But if you want it to be like hyper aware of what your data is, that's where you're going to want to fine tune and say, no, this is take what you already know and supplement it with this very specific information. And we can do that, and JumpStart makes that easier to do.
Yep. Yeah, so with JumpStart, like as I said, right, like it's a model hub where you can discover all the foundation models. Like we have like providers like Amazon, Hugging Face, Meta, Cohere, AI21. You can discover foundation models from these providers, and then we offer like model cards for all the models from these providers. For instance, like for Meta, like we have Llama, Llama 2, Llama 3, and now Llama 3.1. And you can discover all the information about these models, kind of pick what's best for you. And going to your point that you brought up, Todd, like that, hey, there are models with different parameters and things like that, right? Like some of them having like lesser number of parameters, some of them having really large parameters, right? Like, so depending on your kind of the use case you're going after and the kind of precision you're looking to solve that use case, you can pick like models like with different parameter size, and then and then with JumpStart, like kind of fine tune them using the kind of the UI based experience that we have.
Yeah, this is one of the things I love about JumpStart too, because when you're browsing foundation models in JumpStart, it actually gives you really great information of the description of the models, what it was trained, what it's good for, some use cases for that model. And then I've even seen some cases where there's a sample notebook where you can kind of get started using that model. So it really does a great job of helping our customers along with how to use these different foundation models. But today we're talking about the launch of Llama 3.1. So this is presumably an iteration on the Llama series of models. Anything you want to say there before we jump into a demo?
Yeah, so Llama 3.1 is the latest of the Llama series from Meta for the Llama models. It comes in like 3 variants, and like there's a 70B model, there's an 80B model, and there's also a 405B, and you can also have an instruct variant for each of these models. And you can find all these models on SageMaker JumpStart, and these models are capable of they're pushing the boundaries in terms of the performance benchmark that we had with Llama 3, and also like they have a broader support for more languages and larger context windows. So you can discover any of these models and kind of one-click deploy, as well as kind of fine-tune them on SageMaker JumpStart. And I think we're going to go into the demo with James kind of walking us over through the journey for customers to try this feature out.
Yeah, while we're bringing up that demo, Adrian, how's our chat looking? Any questions coming in on the JumpStart front?
Lots of Emperor's New Groove references, so I'll start with that. Second, yeah, we do see some questions, just kind of some splendor and wonderment, to use that term, that it really is as simple as you go and you get your menu of what exactly you want to do. Even weighing out the pros and cons proactively, that's speaking to a lot of different dimensions of helping answer the obvious and at times very difficult questions to be able to get the nuance out of. And it just seems genuinely the chat is appreciative of that. And I know I am. I'm not a data scientist, but more and more of my partners and customers are pushing me to go down this way to help them experiment and iterate. And actually, I heard from the CEO Tuesday on them getting stuck with some Jupyter notebooks. So I had to go in there and tinker, get in their shoes and figure it out. You guys make it fall down easy for us. So with that, let's jump right into the demo if we can.
Yeah.
Cool. So what I got here up on the screen is basically what we refer to as SageMaker Studio. And SageMaker Studio is, as Saurabh mentioned, fully managed, so you don't have to worry about any of the instances or the setup. It actually literally took me like 3 or 4 clicks to deploy a new SageMaker domain and click into this experience. But highly recommend everyone checking out if you haven't already. And you can see off the bat, I got menu items as far as applications. If I wanted to, I could stand up a Jupyter Lab notebook, kind of play in that Python playground and whatnot. But, we're here to talk about JumpStart. So I'm going to scroll down here to JumpStart. And Todd, as you mentioned, we have a ton of different models supplied by a lot of providers. And you can see here off the bat, in this particular instance, I got 19 providers available to me. You can see Meta up there, front and center, with 51 models. But just in case, if you wanted to filter that down, I can go ahead and put something in the search bar. And if I click on Meta, I'm going to see all the models that are available on JumpStart through Meta, right? And today we're talking about Llama 3.1. For me, it's been an awesome model. Customers love it. The capabilities, how it performs on benchmarks is, it's pretty, world class. And, I can filter down again the number of models by putting, let's say, 3.1 to limit my search results to the 3.1 model. And then you can see the 6 models that Saurabh had mentioned.
That's right. So we see a number too. We see a couple different things in that name there. We see that 405B. I imagine that's some indication of the number of parameters that went into this model. But we have a question in our chat too that's directly around context length. So within interacting with some of these models, there's a context that gets provided so that we can query these models in different context lengths. And the question is, what dictates the context length limit?
Yeah. Go ahead, James. Do you want to take that?
No worries. Yeah, so there's a few different things that go into what a model supports. So first of all is the actual model itself. And so with these new Llama 3.1 models, they support, I believe it's 128,000 tokens or context length. And that's the first piece of it is, what's the model provider done to architecturally support a certain context length? And then in practical use, and what you'll see, as you interact with, let's say, SageMaker is, depending on the instance types that you select, beefier hardware will generally be able to max out that 128K token support. Whereas if you want to be frugal and be super fast, you can pick a smaller instance. You just might want to be aware that you're going to be able to, be limited to a limited number of tokens there.
Oh, so you have some control. You have a little bit of flexibility in that based on the size and the model that you select. That's very cool.
Yep. And just adding to what James said, Todd, we put a lot of sweat and tears to since we have a one-click deploy experience on JumpStart for different instance types, we put a lot of sweat and tears to make sure that we are able to hit the max context length for a given instance type for a given model, right? So let's say for Llama 70B, you could get the full context length 128K on a powerful P5 instance, right? But if you want to run it on a P4DE, we still support a good amount of context length, and we've put a lot of work to make that happen. So it's for each of the instance types that you see, and James will get to it in a bit. We kind of try to support the most context length that based on some of the science improvements and engineering improvements on our side.
Very cool. Okay.
Yeah. So to dive right in, I'm just going to choose the 3.1 version and the 8 billion parameter base model.
Okay.
And this is a great screen. It's what we'll refer to many times as like the model card, and you get all the details of the model as far as, the types of, the sizes, as well as the data set it's been trained on. As long, and I won't bore you with it, but, as JumpStart kind of entails, we can jumpstart your activities such as deploying the model. And you can see up here, I have a deploy button. And through this UI experience, I can actually, with a few clicks of a button, deploy this model. So it's going to ask me to accept the EULA, specify a name and an instance type. And literally, I can click deploy here and have a SageMaker endpoint that is running and hosting that model that I can run inference against. And likewise, if we go back a little bit, in addition to deploying a model as it is in JumpStart, let me go back to the model hub real quick. Going back to 8B, you can also see that I have a couple different options here. So in particular, I have this train button. And if I click on that, I actually have the ability to, as mentioned earlier, fine-tune Llama based upon my own data set. So what you do is you basically specify a data set that's contained within an S3 bucket, as well as some hyperparameters or knobs and switches to get the best model possible. And ultimately, again, you choose your instance type, and further down the line, you can click submit. And SageMaker is going to do all the heavy lifting for you. It's going to grab that training data, fine-tune your model. And for the sake of time, I've already done that. So if I click on jobs in the left-hand column, I can go to training. And you can see here one of the training jobs that's completed and succeeded. And this was a job I ran earlier in the week that took a data set that essentially fine-tuned that model. And after that model was fine-tuned, I can click deploy to create another endpoint. And same as before, filling out a few different fields, clicking deploy, and deploying, in my case, 2 different SageMaker endpoints. And so to show you guys, and I thought this would be kind of fun, I deployed the base model as it is out of the box, as well as a fine-tuned model to see if we could see some differences in the performance. So if I click on endpoints, you can see here I got the 2 endpoints, right? The first one is named JumpStart-DFT, blah, blah. That's my fine-tuned model. But I've used a data set to kind of cater to, again, getting better results for my particular use case. And then bottom, a little below that, is the base model. So I'm going to click on that base model, and you can see the entire endpoint details here. For us, I'm going to click on test inference, and you could run inference straight out of the UI, which I think is super cool in JumpStart. And I have a prompt here that I've created, and I'm basically going to say, hey, can you describe the process that you would use to generate answers? Please provide a step-by-step explanation. I can send that request to SageMaker to get that inference result. And you can see with the base model here on the right side, you can see the results. It's not that great of a response, right? I'm trying to understand how to generate answers. I'm not sure what you mean by generate answers, and then it kind of repeats. But let's take that exact same prompt with the exact same parameters against our fine-tuned endpoint. And I'm just going to navigate to it real quick. And I'm going to do the exact same thing. I'm going to go to test inference and supply that same request in JSON format. We're going to click send request. And you can see here, I have a way better response coming from that model because I fine-tuned it. So it says, thank you. The process that I will use to generate answers is as follow. 1. I start by reading the question carefully to make sure that I understand what is being asked. 2, yada, yada. But it really gives you an idea of like the power of fine-tuning and just how easy it is to do with SageMaker JumpStart. Wow. Now, yeah, one thing I'll add is like, this is all UI driven, so that's super easy, especially if you don't know how to code. But everything is also available through our SDKs like Bodo or our SageMaker SDK. So super easy whether you code or not.
Cool, cool. This leads me to a popular question I tend to get asked a lot, especially given how it's almost a race condition to be able to find better ways to simulate the type of data that you're going to be leveraging. Can this be leveraged to go about with synthetic data generation, or is that kind of outside of the scope of it?
Yeah, so interesting question, Adrian. So yeah, so like Llama 3.1 models can be used for synthetic data generation, right? Like so, and our customers are excited about it. And so with synthetic data generation, what you could do is kind of use the 405B model, which is kind of the model which has a lot more larger number of parameters, kind of use it to generate synthetic data, which essentially is like data generated by a model that you can use to fine tune your subsequent model. And and then as you're generating the synthetic data, you could kind of generate it in a way which kind of mimics your actual data of or the kind of the domain that you're looking for. So what we have seen our customers kind of speak to is like using the 405B model to generate synthetic data and then kind of fine tune the smaller versions of the Llama 3.1 model, right? And so they get kind of the broad data set, right? Like without actually going and labeling the data, and then having a lower footprint when it comes to running these models at scale, because they've fine-tuned the smaller versions of Llama 3.1 models using a lot of data which is already kind of although synthetically generated, but more relevant to their domain.
Yeah, that's a really cool thing. This idea of synthetic generation. It's not something I've thought about because it never occurred to me that you could just create data. Now, James, I want to go back to something you mentioned. You said we have a user interface that you can do this through and interact with this, but we also have some constructs in our API and in the CDK. What about Terraform? We have a question in the chat. Somebody's asking, can we do this through Terraform if we wanted to?
Yeah, so I'm not super familiar with Terraform. I do know that I believe it's SageMaker constructs. So my expectation is that it probably would, or if not, would be supported pretty soon. But unfortunately, don't know off the top of my head.
Yeah, there's a bit of a keep up with the Terraform and the constructs that we develop for AWS, but I imagine SageMaker is a part of that, and I'm sure there's documentation available online where we could start to see some of the constructs in SageMaker for Terraform. So, Rob, were you gonna answer?
Yeah, no, I was gonna say like there's a blog out there which talks about like customers like deploying models through managing their infrastructure through Terraform for SageMaker. I'll have to dig that up and I'll put it on the chat like once we're off the camera.
Yeah, for sure. Hey, this is really cool. I love seeing SageMaker in action. The idea that we can interact with some of these massive models in this like the frontiers of computing with generative AI with just a couple clicks of a button. Like I could literally just click deploy and I have an endpoint that I can start sending requests to and getting inference and generated response. It just blows my mind how far we've come and how easy AWS has made it. Thanks for coming on the show. Where can our audience go to learn more about SageMaker JumpStart, Llama 3.1, the models that we have available there?
Yeah, there's a bunch of launch blocks that we've put around, like using Llama 3.1 and JumpStart. Or if you're already familiar with JumpStart, like you can, or SageMaker, you could go to JumpStart, discover the model as James did, and just go ahead and try out Llama 3.1.
Yeah, just like that. Just a couple clicks of a button. That's awesome. Hey, thanks for coming on the show. We're going to have you again, I'm sure. SageMaker's always doing new stuff, so we'll see you next time.
Sounds good. Thanks for having us. Yeah.
All right.
Thanks. Yeah, action-packed show for sure. This is got to be ranked up there, easily top 3 of my favorites.
Dude, it just blows my mind. Like I can remember when I first started understanding like AI. It's a couple years ago, well, more than a couple years ago, and I was trying to understand inference and training and all these different things. And I almost needed like a math major to even try to wrap my head around it. It also brings me back to like my college days of even just like we talk about EKS and distributed computing. Like I remember like my college professors doing dissertations on distributed computing, and now you just hit a few commands and you can be up and running with like a HyperPod cluster. It's wild.
It is wild. I still remember writing the ancient, I'm gonna date myself, writing the manifest and build docs to deploy Solaris containers in LDOMs. Doing this, building Novell stuff with Ghost and Pixie Boot. This is just that on hyperdrive, probably something that circa, early 20s Adrian would never have seen possible. It's pretty cool and exciting. And no matter where you are in tech, I think you're in the right place to continue to start picking up, learning, and going and doing some things that people thought were impossible even 5 years ago.
Boomer confirm. Hey, boomers can still be techies. So let's not discriminate here.
Hey, to be completely fair, I think I'm borderline older millennial. I think there's a term called Zennial where we identify more with Gen X. I mean, every test or quiz I do or people give me, definite just Gen X affinities. But hey, it is what it is. It's conversation for a nice frosty beverage, or in my favorite case, a good glass of a nice peaty whiskey this time of year around a fire pit with your friends.
Yeah, nice for sure. I like the term elder millennial. It makes it sound like it's got some wisdom and
Dignified.
some important, yeah, dignified. Yeah, and for some reason this show always makes me want to just get nostalgic, and because I see all this new stuff and I'm thinking, holy cow! Every time my mind's blown, I'm just like, this is so much easier, and just at a scale that I never even could have imagined. So, really cool stuff. Hey, tell us, we want to know what you thought about that. If you've got some nostalgic old tech stories you want to share, we can maybe bring them on the show next week. Go ahead and fill out our survey. The first 20 respondents will get $19 in AWS credits, and beyond 20, again, I'm going to bring this up every show until we hit that 100, because I really do want to kind of write this song, this metal song about, I'm actually probably going to have some, maybe this Llama model write the lyrics to that. I think I shared with you, Adrian, Adrian and I are both kind of metalheads, so we can kind of riff on music and different things. I really want to write this song. So over 100, but it's got to be before reInvent. And speaking of reInvent, Adrian, it's coming up.
It is coming up. I think this marks my 9th one that I'll be going to. I think I kind of lost count. So if you've never been to reInvent, it's definitely one of those things that I would recommend for technical career progression, even business career progression. The hallway track is definitely something that folks talk about and look forward to. But notwithstanding, there's something for everyone at every level or phase of your journey into IT world, or even just into computing all up. There's going to be something for everyone. So by all means, if you have means or are interested in learning more, go to the reInvent page, learn more. And even if you don't go, you can absolutely jump on that free live stream, learn as you go, dig into those YouTube sessions and the video on demand stuff. And of course, we'll be there helping you catch up, learn about the coolest launches, and share our thoughts and wax poetic about the good old days. Probably.
Yeah, for sure. This will be my second. Last year was my first reInvent. This year will be my second reInvent. I will be there hosting OnAir. Also be running some workshops on the AWS Solutions Library, and I'll be talking at a Chalk Talk. So I would love to see you, meet you, December 2nd through the 6th, I believe, this year in Vegas. They always say it's the biggest tech part or biggest party in tech is at AWS reInvent. And I'm here to confirm that is true. My mind was blown on the replay party. I'd never seen anything like it, never been to anything like it. So that's a huge plus. So yeah, check out the reInvent and let's meet. Adrian, you got anything else for us this week before we wrap up? Big plans?
I was saying, you totally said it. You nailed it. You did a fantastic job there. As far as big plans, we're gonna do something for the kids here in a little bit. My son had his first Little League or T-ball game a couple days ago. They won. It was a big deal for them. And yeah, we're gonna go out and just treat the team, have some nice. I believe it's just gonna be pretty low key, like pizza soda type thing.
Yeah, maybe start a fire, cozy up next to a fire, and get some of that pumpkin spice lattes on the stove, and enjoy the fall as it quickly approaches.
No, it's 95 degrees again in Texas. We had our first taste of fake fall, so no, there will be no fire or fire pits this weekend. It's still a little too hot, but I will take you up on that. We'll riff and figure out what the key of that metal tune is going to be. I'm confident we're going to get some surveys in this week.
Oh, I'm thinking squealies. I'm thinking chugging.
I'm ready. All the chuggas. I want it all.
Yeah. I'm gonna go play some guitar. Hey, I think that's all we have for the show this week. Adrian, thanks again. It's always a pleasure hosting with you. It's always so much fun, and I can't wait to do it again.
Sounds good. We'll see y'all.
All righty, take care, everybody.